LVDT circuit. The input of the LVDT from a 40 kilohertz input to LVDT, and then ground. Now the outputs, we separate two outputs. One output, like VA, is going to the half wave rectifier. Second output from the LVDT is going to 40 kilohertz filter. From the 40 kilohertz filter to the input of the full wave rectifier for the double wave rectifier. And then the output, the first output of the full wave rectifier is going to instrument amplifier terminal plus. The second input of instrument amplifier is coming from the conductive potentiometer. Conductive potentiometer connected to plus and ground. Then adjust, we put the LVDT on 0 position, and then we adjust the potentiometer to get output 0 on the instrument amplifier. It's like a 0 position of the LVDT, adjusted by the potentiometer to bring the scale, to bring the voltage at 0 when the LVDT at 0 position. Second step is to bring the second output from the wave rectifier to differential amplifier terminal plus. Then the second, or the terminal minus of the differential amplifier to terminal C of the carbon potentiometer. Carbon potentiometer A on 5 volt and C on ground. Then we adjust the voltage, then we adjust the potentiometer to get a voltage from differential amplifier to be 0 when the LVDT at 0 position. Then we take the output from the differential amplifier to amplifier number 1. Then we set the gain chorus to 1 and the fine gain to around 0.5. And then we take the instrument output, the output of the instrument amplifier to the amplifier number 2. And we set the gain to 10 and fine gain around 1. In fact, depends, you will change the gain until you get a reading, to keep the reading around zero when it is when the LVDT in 0 position. Reading will be around 0. Then we take the output from the amplifier 1 to inverter, and then the inverter to summing amplifier input number A, and then from amplifier 2 to summing amplifier input number B, and then C we can of the summing amplifier we can ground it, and then we measure the output from here. In this way the LVDT will read from -5 to 5, so we can find the direction of displacement. If it's like -5, it's right side. If it is +5, is left side, and what's in the middle, it's in the 0 position. So if the LVDT goes right, or left, we'll measure the voltage like this. It goes, it's -5, and it goes in this direction, it's 5 volt. And when we set the LVDT around 5 in the right direction, we'll get around 2.9 volt. And if we set on the other side 5, we'll get almost the same, minus 2.8 volt. In this way that the LVDT will work as per the concept of LVDT.